We're going to start this video off talking about order of operations. Here's one example where we need to use the order of operations in particular. The thing to keep in mind when talking about order of operations is often referred to as PEMDAS. It's an acronym to help remember the different steps to take. PEMDAS stands for 1, parentheses, what basically means we do what's inside the parentheses first, and then work our way outward. And then once we take care of what's inside the parentheses, we go to step 2, which is to raise anything to the powers, which means to take care of the exponents. And then the M stands for multiplication, so we're going to work the multiplication from left to right, and then do the division operators from left to right, and then followed by A for addition, and then finally any subtraction that's left. So these are the order of operations in order to properly calculate something that has many different operators involved. And we see that in this example here. So the first thing I'm going to do is take care of what's inside the parentheses. Sometimes they also look like brackets as well. So here what's inside the brackets, I'm going to take the 3 to the second power, and since 3 to the second power is 3 times 3, I'm going to put a 9 there instead. And then the next thing I'm going to do is take care of the minus negative 5. Minus negative 5 is same as positive 5. So make it 9 plus 5 instead of 9 minus negative 5. So we're still working on what's on the inside of the parentheses. Now we're going to go ahead and add together 9 plus 5 inside the parentheses to get 14. So now it's turned into 14 raised to the second power. So now we've taken care of what's on the inside of the parentheses. Let's go to the next step, which is to take care of the exponents. So notice there are two things raised to powers here. We have 9 squared, which is 9 times 9, or 81, and 14 squared, which is 14 times 14, which is 196. So now what this is going to look like at this point is on top we have 4 times 2 minus 81, and then that's all divided by 196. But the next step is to do multiplication. Multiplication means I'm going to multiply 41 times 2, and that's 82. So on top we have 82 minus 81. All on top, and then on the bottom is 196. Now notice that there's not any immediate division or addition that we have to do. The only thing left really is subtraction. So we have to subtract the two numbers on top. 82 minus 81 gets a 1. It looks like 1 over 196. And that's all we have left to do. The last answer here would be 1 over 196. So let's go through those steps one more time. First thing we did was we took care of what's on the inside of the parentheses. 3 squared to give me 9. Then negative 5 is positive 5. 9 plus 5 is 14. And then we square the 9 and square the 14. We multiply 41 times 2. And then we finally do the subtraction on top. And that takes care of everything by order of operations. Another thing that's good to go over is simplifying things using the like terms and also order of operations. So in this one here, let's talk about what a like term is. Like terms are terms that have the same variables raised to the same powers. So for instance, things that are like terms are things like 2x squared, x squared, negative 3x squared. These are like terms. Also things like 2xy, 3xy, or negative xy. These are also considered like terms. Things that are not like terms would be things like, say, 2x squared y, 2xy squared, or even just 2x squared. These are not like terms. They have to have all the same variables, so both x and y, and also be raised to the same powers all at the same time. So let's look at one example in particular here. Let's look at 12 x squared plus 4 minus, then in brackets, 9 x squared minus 5 plus 2. Okay, so first thing we need to do is to take care of what's inside the parentheses. And we're going to do the multiplication first before we do the addition. So the multiplication, the 9 is in front of the parentheses, which means we have to multiply that 9 inside the parentheses. Sometimes that's called distribute. So after we do that, we'll write down everything. We still have 12x squared plus 4. And then we're going to have minus. And then we're going to have 9x squared minus 45 plus 2. Now we can go ahead and add together the numbers. In this case, we're going to take the negative 45 and the plus 2 and put them together. So we're going to have here 9x squared minus 43. We're still working on what's on the inside of the parentheses. Now it's in the parentheses and there's something out in front, namely that we have this negative out in front. That negative, just like we did the 9 up above, will be distributed into the parentheses. So we're going to take the negative and put it to each term inside the parentheses. We're still going to have here in the front the 12x squared plus 4, and then if I distribute the negative, it'll follow up with negative 9x squared. Negative 43 will be positive 43. Now we can see what are like terms in this case. In this case, notice how there's x squared. So we can combine the like terms and also the numbers together. So when I put together 12x squared with negative 9x squared, 12 minus 9 is 3. So we have 3x squared. And then when I put together 4 plus 43, that's going to be plus 47. All right, so that's one example of combining like terms. Let's look at another one here. Negative 9x cubed plus 7x squared minus 5xy plus 3 minus, and then in parentheses, 13x to the third plus 2x squared minus 8xy minus 6. First thing I'm going to do is to take the negative here that's in front of the parentheses, and I'm going to go ahead and distribute it into the parentheses. There's nothing to combine at the moment inside each parentheses, so we're just going to kind of have to take it from here. I'm not going to have to continue to use parentheses on everything since there's nothing to combine together at the moment. So let me drop the parentheses in front of the first set of terms. And then after distributing the negative, it'll be negative 13x cubed minus 2x squared. Minus minus makes it positive 8xy, positive 6. Okay, and now we're going to look for how we can combine like terms together. So what are the like terms? Well, for instance, we have a negative 9x cubed and a negative 13. If we do negative 9 minus 13, that's negative 22 x to the third. Okay, so let's go ahead and put those together. And then we'll look at what's left and see if are there any other like terms that we can put together here. Well, notice how we have the 7x squared and the negative 2x squared. We can add those together. We can also put together the negative 5xy with the 8xy. So we'll have here negative 22x cubed plus 5x squared. The negative 5xy plus 8xy gives us 3xy. And when you add together 3 plus 6, that would be plus 9. All right, now that puts together all the like terms, combines it all together, and simplifies it to this one here. Now let's talk about multiplying things together with some more operations here. Now we've already kind of done what we see here in the first step. First example, 3x to the fourth times 2x cubed minus 7x plus 3. There is one thing that I'll have to make a little extra that we haven't seen so far in the last few examples. But first thing to do is something that we've been doing with the multiplying into the parentheses by distributing. So what I'm going to do here is distribute, multiply to each term. Now something to keep in mind when you multiply terms together is when they have the same variables, then you're going to add together the exponents. So when I do this with the x's, the powers are going to add together. Okay, and so for instance, what I mean by that is, for instance, if you take 2x squared times 3x cubed, you're going to multiply 2 times 3 to get 6, and you're going to add together the powers, so the 2 plus 3 to have it x to the 5th power. So in this particular example, we're going to multiply 3x to the 4th times 2x to the 3rd. That's going to be 6x raised to the 7th power. And then when I multiply 3 times negative 7, that's negative 21. And then you have x, which is technically x to the 1st power, and x to the 4th power add up to be x to the 5th power. And then at the very end, we multiply by 3. 3 times 3 is 9. So we have 9x raised to the 4th power. And that's all we have here. Okay, now in the case of something like x plus 7 times x plus 3, we go through a step-by-step process which is often referred to as foiling the two together. FOIL stands for first, outer, inner, and last. So what we do is we take the first two, the x and the x, and multiply them together. Then we do the outer, which would be the x and the 3, multiply them together. The inner, 7 and x, multiply those together. And then the last, which would be 7 times 3. So when we start with the first, x times x is x squared. The outer would be 3x. The inner gives us 7x. And then the last, which would be 3 times 7, would be 21. Okay, and then we can put together like terms if any like terms are here. In this case, we have 3x and 7x, which combine to be 10x. So x squared plus 10x plus 21 is how this turns into what this turns into when we multiply it together. Here's another one where we're going to have x plus 5y times 7x plus 3y. We're going to FOIL these two together. Now, if you'd like to try a practice one on your own, this is a good one. You could pause the video here and see if you can write down a few steps of FOILing these two together. As we did in the last one, we have to multiply the first. So x times 7x would be 7x squared. And then we have to multiply the outer, which would be x times 3y, which would be 3xy. And then we have to multiply the inner. 5 times 7 is 35 xy. And then we have to multiply the last together. 5y times 3y would be 15y squared. Notice how the middle terms both have xy in common, so they're like terms. So we can combine the middle 3xy and 35xy, add together to be 38xy. We put that all together, and that's the result of FOILing those two things together. Something else that's good to take a look at is when it has a two-term expression like 5x plus 4 and the whole thing raised to the second power. In a case like this, what we have to do is treat it as if we're multiplying it by itself. So we have to take the 5x plus 4 and multiply it times itself, 5x plus 4. That's what it means to be raised to the second power. Once it's written this way, then it becomes a process of foiling it. So if you'd like to practice it again, this is a good one. You could pause the video here and see if you can FOIL these two things together. If I do the first 5x times 5x, I would have 25x squared. If I multiply the outer, 5x times 4 is 20x. The inner also would multiply together to be 20x. And then finally the last, 4 times 4 would be 16. So when you put this all together, 25x squared plus 40x plus 16. Something else that's important to review over is the concept of x and y intercepts in a graph. So here I have the graph, which is the graph of a straight line that goes off in both directions forever. And this graph crosses through what we call the x-axis, which is what runs from side to side, from left to right, and the y-axis, which runs up and down. And so there are points in many graphs where it crosses these different axes. In this case, where it crosses the x-axis, that's what we call the x-intercept. And where it crosses the y-axis, that's what we refer to as the y-intercept. So that's all we have to do on this one, is just identify those points where they cross. In this case, the point where it crosses the x-axis would be considered the point 1, 0, and the point where it crosses the y-axis would be considered 0, 6. So one thing to keep in mind when talking about x and y intercepts, the x-intercept is where y is equal to 0, so that's why we see it at the point 0, 1. And the y-intercept is where we see the value of x is equal to 0, where it crosses the y-axis. That's why the point looks like 0, 6.